In this video, we're going to review linear equations, and this is going to help set the stage for least squares regression in the next set of videos. So we're going to work with lines in which we're going to describe how two quantitative variables may be related to each other. And we're going to do that with data. But before we get there, I want to review the equation for a line. Now, there's different ways to express this, but one of the most common ways is with y equals mx plus b. This is called the slope-intercept form of a line. This is called the slope-intercept form of a line because the slope given by the number m is immediately available, and so is the intercept. And when we say intercept, we mean the y-intercept. And so the letters y and x, in a statistical perspective, those play the role of the different variables in a study. So you might have the response variable and the explanatory variable. And another note here about the y-intercept. When we say a y-intercept, we're talking about lines. So here I've got an example of a line in pink. The y-intercept would be the location of this point in blue because it intersects the y-axis. So the coordinate here would be 0, b, because if a point lies on the y-axis, its x-coordinate must be 0. Now here is a very generic example of a line that has been drawn on a graph. Can we say anything else about this line? For instance, can we tell by looking at it whether the slope is positive or negative? That slope, looking from left to right, it sort of goes downhill. So we would say the slope is negative. So here I wrote less than 0, which is the same as negative. Let's look at some other examples of linear equations. Let's consider the equation of the line represented by y equals 2x minus 5. Here, the slope is a 2, which is positive, right? So we'll draw that so we can see what that looks like. The y-intercept is not just a 5, but a negative 5. So that would be the coordinate 0, negative 5. And when we think about slope, a way to interpret slope is as the change in y over the change in x. That's why people sometimes call this rise over run. Let's graph this line. So I've got a set of axes. I've labeled the horizontal axis as x, the vertical axis as y, and I'm going to graph what I know. So we were given this y-intercept, right? That's why it's called slope-intercept form. That y-intercept is really obvious. So I'm going to plot a point down here at 0, negative 5. And when I think about slope, I'm going to think about rise over run, change in y over change in x. So if I'm going to plot a couple more points so I can draw a line, I'm going to think about this 2. Maybe I want to think about it as a 2 over 1, right? Because we don't really write over 1, but that's going to help me think about, I want to draw a point that goes up 2 spaces, but over 1 space. I'm going to draw another point that goes up 2 spaces, but goes over 1 space. And one more time, just for the thoroughness of it. Okay, hopefully those are visible. And now I am ready to draw a line that goes through those points. I'm going to draw this line in pink here. There we go. For clarity purposes, I'm going to just label a couple of these blue dots here. This one I know has an x coordinate of a 1, but has a y coordinate of -3. How did I do that? Because if we started at the y-intercept, we went up 2 spaces. So I did -5 plus 2. But I also went over 1 space to the right. So I went from 0 to a 1. Can you determine what this point was? Well, let's see. We went up 2 over 1, up 2 more over another 1. So this is a x coordinate of a 3 and a y coordinate of a +1. Where we are going to take this in the subsequent videos and for this chapter is imagining we're going to create lines, but we need to create them based on data that was observed or measured. So I'm going to scroll down a second here. For instance, what if you had an explanatory variable and a response variable that you were interested in, and each of these dots represents some measurement from those variables. And there's going to be variability in those measurements, right? They're not going to necessarily follow a perfect line, but our job as statisticians is going to be, how do we describe the relationship here between x and y? It appears that as x goes up, it appears that y goes down. So that would imply there's like some negative slope here. And so where we are headed in the next couple sections is, how do we get this line? Based on data, how are we going to describe this relationship between x and y if it follows a linear shape? So that's coming up. See you there.